In Chapter 7, we would like to introduce another useful example model in a steady-state simulation. Model 7-1 is a small manufacturing system. We are going to introduce a base model in this chapter and improve it in Chapter 8. We are also going to conduct statistical analysis of steady-state simulations with this model. This is the workflow of the small manufacturing system. There are 4 cells. Cells 1, 2, and 4 has 1 machine each. Cell 3 has 2 machines with different working speed. We assume that the transfer time between any 2 cells are 2 minutes. We know this is not realistic and will improve this in Chapter 8. For entities, there are 3 part types, and each type has certain percentage. Each part type follows different routes with various processing times in triangular distribution. Obviously, the different routes for each part types are making things complicated, because if we only have 1 part type and 1 route, then this is as easy as the electronics test and assembly model we learned in Chapter 4. We can still use stationary route module as we used in Chapter 4, but we need to have more weapons to handle the new requirements here. We will use sequence module to handle multiple routes. Each step in a sequence can have attribute. For example, each step may have processing time. Once we define sequence, Arena will direct each part to follow its correct route to finish processing. Before we define sequence, we should define all the stations first. In this model, we have 5 stations: cell 1, cell 2, cell 3, cell 4, and exit. Sequence module is in advanced transfer panel. Each row is a new sequence. Each sequence has multiple steps. Each step has 1 or more attributes. To make it easier to use, we organize the 3 sequences into an advanced set, part sequences. Then, right after entities are created, we use assign module to determine part type, which is indicated with a user-specified attribute part index. We assign the part sequence according to part index. Entity.sequence is a built-in Arena attribute for entities. In route modules, we use by sequence rather than station. This is an example of route module using by sequence. The route time is using a variable transfer time. Entity.sequence, entity.station, and entity.jobStep are built-in Arena entity attributes. We noticed that in the sequence definition, we did not specify the processing time for cell 1. In fact, we could have specified the processing time for cell 1 similar to other cells as well. Alternatively, we present another method to specify the processing time for cell 1. We define cell 1 times as an array of values in expression date module. We refer to cell 1 times in the cell 1 process module. In order to model the different working speeds of 2 machines in cell 3, we use factor variable. Factor variable values are referred to in the cell 3 process module. 3 sets were defined. The first set is a resource set with 2 cell 3 machines. The resource set cell 3 machines are referred to in the cell 3 process module. The second set is for part pictures. They are referred to in the assign module. The second set is for entity types. They are referred to in the Assign module 2. For the run setup, we run it for 32 hours. We customize the entity pictures for the 3 part types. We discussed a lot of nuts and bolts of the model already. Now back to model 7-1. Create module creates the entities. Assign module, as we have seen earlier, assign several things. After sequence is defined and assigned to the parts, the rest of the model will use station route pairs to route the parts through different cells. Cell 1 uses station, process, route combination. For delay time, it uses the expression cell 1 times, as we discussed earlier. Cells 2 and 4 logic are similar to cell 1. For delay time, they use process time, an attribute of sequence step. Cell 3 logic is similar to other cells. For delay time, as we have discussed earlier, need to use factor variable to model 2 different machine speeds. Finally, we need to have an exit station to indicate the end. Next, we would like to create animation. The layout was imported from an AutoCAD file. We have introduced the relevant animation elements before: resource, queue, station, and route. This is the overview of the final simulation model and its animation. A critical criterion for assessing a simulation model is validation and verification. Validation asks whether the model is equal to the real-world system. Verification asks whether our implementation is done as we wished to model. There are multiple ways for verification. Basically, this is a debugging process to find out whether there are any programming errors or logic mistakes.